So, I think we need to build a gas forge. Sound good?
Yeah, for sure. I mean, let's do it. Let's build a gas forge. Let's build a forge.
Okay, here we are, folks. We are using material off of an old mobile home trailer frame. And those are the wing pieces that were on there. It's the first time using this material. It's essentially just plate steel, super thin, probably 3/16 of an inch at most. So we got a lot of work out of our plasma and the new shop. So pretty outstanding. Loving every bit of it. Just cutting the flanges off. Almost every piece that comes off of this will be used in the build here of this forge. Just laying them out here. We've just kind of a dog-eared corner on one of these. We're going to take it over here to the anvil and straighten it out just a little bit. Alright, so we're cutting our top and bottom plate. Now this is like 1/4 inch plate, maybe closer to 3/8 plate that came off an old oxyacetylene rack that I had floating around the shop. I don't have oxyacetylene right now set up. I have the bottles, I just need to get them filled. And they'll just be fixed in place on like 25-foot cord hoses. So I'll be able to reach any place from the shop. We're just cutting all the door sections right now out of some angle iron. And this is all repurposed stuff. Like, none of this stuff is new except for the burner parts. It's the only parts that are new. I need to get some welding clamps for sure. Make it a whole lot easier than using these screw-in clamps. It was quite the balancing act to get them all on there. So there's a lot of welding in this video. I tried to cut out as much as I can. I mean, once you see it done, it's kind of whatever. But to drive the theme and the narrative and everything, it will, you know, be a considerable amount of welding within the video. You just won't see every little bit of it. You see the beginning of it, end of it, you know, start, stop type deal. We're essentially just making a box. You know, we cut these down to 12-inch square. Wait, no, 10-inch by 12-inch square. So kind of a cuboid, not a full cube, but a cuboid. Now we're going to cut out our door holes here. Now we know that our insulation, our spun wool K-wool, our spun ceramic wool is 2 inches thick. So we are dropping off, adding in the thicknesses of the plate. So we're 1/8 to 3/16 and 1/4 inch, you know, so we're bumping those down, and so that we have a good measurement of where everything is. Now we're knocking off the dross that comes from the plasma. So right there, we're just cutting our angle iron for our door pieces that are going to stick out, and then welding them in there. Yes, I wanted to have these doors open and closed, but for the sake of time, I needed to get this thing just done. And that's why one door is different than the other. So I like it though. It was kind of it ended up being an experiment in doors, what type of doors to put into it, since it's a double-sided forge that we're building here so that 2 people can work out of it at once. And when you're at a demo, which I am at quite a bit with my buddy Justin, and I didn't get any I didn't get any footage of this little door being built, so sorry about that. when I'm at a demo with my buddy Justin, you know, we don't need to bring 2 forges, so we just bring 1, and we both work out of it. We have 2 anvils, and there you go. It's a mess. Welds aren't pretty, but that's okay. Using flux core, welding 2 different thicknesses of multi-thicknesses of metal. I mean, you're going from 1/4 inch to 1/8 inch to 3/16. It's ridiculous. All right, so we're just marking up the top here, getting ready to put in our burner hole. And there's the burner. Now we're using 0.035 MIG tips for the nozzle, which I needed a shorter. You need a shorter standpipe for those. The 0.030 nozzles really like a 10 to 12 inch standpipe, so I think that's an 8-inch standpipe. Now I was going to try and build a different burner here, and I actually did build a completely different burner for this, but it didn't work. It only works for forced air, not atmospheric, unfortunately. Now I did a little bit different here when we welded this. I got the in-between sections. I didn't get the flashes. Did it on purpose, you know, to kind of give you guys a break from all the flashy stroby lights. Okay, and like I was saying before, this is a spun ceramic wool, commonly known as K-wool or kaolin wool. This will be the bottom piece here. And this is a traveling forge right now, so it will not get a full bunch of refractory on all the sides and the ceiling. If this, or not if, but when this turns into just a forced air shop forge, it'll get a full coating of refractory on all the insulation. As you'll see later, we just poured a small table in there, and that will be what our material rests on. I do like this forge. There's not a lot of heat that escapes, because it has these square corners. It's a box within a box. And so it has to, can't just shoot straight out like a tube or like the propane canister forges that I normally build. It has to go around corners, and so it keeps a lot of the heat centralized within the box. It's definitely a lot easier to put this in here. I mean, you would think it would be easy with the other ones too, but since you are going around a radius on the cylinders, it's a little bit more difficult to get everything right. This way, it's all right angles. You just measure and cut. Right now, we're taking a hole saw and turning it backwards to make sure we get our hole in there. And I'm spreading out the bottom part of that, kind of shaping it so that the flame profile widens out a little bit as it gets inside the oven portion of the forge. I'm going to fit that all in there. It sits on there right nice and tight. Now, technically, I probably didn't need to freaking weld the top on, but since it's a travel forge right now, we went and welded the top on it. Fires up really nice. Heat's really nice. Like I said, not a lot of escape out there. We mixed up about, I'd probably say half a gallon of refractory here. This stuff's rated to 2,500 degrees. And I cut out, so that's 2 inches thick, and I cut out about 5/8 of an inch thick. So I took away about 5/8 of an inch out of that 2 inches, and we'll then pour our table into that. So it's still insulated underneath. Don't be afraid to get dirty. You gotta push that refractory around. And now go to wash the hands. And here we go. We're gonna fire it up. Now that refractory is wet, but you can still fire it and it won't crack. Keep it low, let it build. You know, just keep it nice and low. Build heat into it. Then when it starts to get a little bit white on top, you'll see here in a minute where we kind of turn the pressure up. There it is right there. Turn the pressure up a little bit. And it's fully cured now after having all that heat into it. Pretty nice forward. Patty turned out pretty good. She's not pretty, but she does good work. She does good work. So, all right, everybody. Hope you guys enjoyed the video. Thank much for viewing, and we'll see you on the next one.